Hey guys, so in this lesson we're going to learn all about the relationship between lines that are parallel to one another and those that are perpendicular to one another. So the first question I have is, what does it mean for two lines to be parallel to one another? Well, if you ask me, I think that parallel lines are lines that, well, they never ever get any closer to one another, they never get any farther from one another. If you were to extend them forever and ever, they would never intersect. And that's really what I believe the definition is two lines that will never intersect. And what I've done here is sketched two red lines that I consider parallel to one another. And so the question I want to ask you is, what is the relationship between the slopes of these lines? Can we make any inferences from looking at their graph and say what the slopes of them might be or how they might relate to one another? Well, I think in order for these two lines to never ever get any closer, never get any farther apart, and never intersect, they need to have the exact same slope. And so in general, parallel lines are always going to have the exact same slope. But one thing I will say is that they do need to be different from one another. If I had drawn the exact same line on top of this, I would not consider them parallel. I would consider them coincident lines. It'd be the same line. So I just want to make a note that it's not the exact same line. Because then it'd just be, well, the same line, not parallel. So parallel lines are two different lines that have the exact same slope, though. And that's the big relationship, that they have the exact same slope. If they didn't, then they would intersect somewhere. Okay, so now let's take a look at some example problems. Let's find the equation of a line parallel to negative 3y plus 7x equals 9, containing the point negative 8, 2. Now, the first thing I think we're going to want to do is we're going to want to actually find the slope of this original line, because then we're going to use that slope for our new line. So let's go ahead and do that first. So I'm going to copy down the original problem, negative 3y plus 7x equals 9. And I think it's a good idea to isolate y in order to find that slope. And it looks like it'll be easy enough to put this into slope-intercept form. So negative 3y equals 9 minus 7x, minus 7x. Let's divide both sides of this equation by negative 3, yielding a nice slope-intercept form of y equals negative 3 plus 7/3 x. Awesome. So I often like to have a little visualization of what this graph looks like, and I'm going to do a very quick rudimentary sketch here on the left. And I think this graph is kind of going to look, I don't know, negative 3 plus 7/3, I don't know, it'll look something like that. And my claim is that there are infinitely many lines that are parallel to this line right here. I mean, you could have this one, you could have, oh, excuse me, I copied and pasted too much. But you get the idea. There are infinitely many lines that are going to be parallel to this one. And we are trying to find the one that happens to go through the point negative 8, 2. So how are we going to do this? Well, here we go. Our original line had a slope of 7/3. And I really take my time to write original slope equals 7/3. And that means that our parallel slope will also be 7/3. And I know this is a little bit tedious to write it all out, but I think it's really good for the reader to see all of that work so they know exactly what's going on. Let me create a little extra space here. Awesome. So now that we have that slope and we've got this point right here, boom, we know that our line, which is parallel to this one containing that point, must have the equation y minus 2 equals 7/3 times the quantity of x plus 8. And this is an equation of a line that will have the exact same slope as this one, parallel to this one, and it will also go through that point. And if you like, we can put this in a slope-intercept form, but I'm groovy with that right there. Actually, my favorite form is to write it as y equals 2 plus 7/3 times the quantity of x plus 8. Awesome. So why don't you give this next one a try? Let's find the equation of the line parallel to 4x minus 5y equals negative 15, containing the point 7, 9. So why don't you pause the video, and when you're done, play the video, and we'll see how it went. All right, so just like last time, the idea is let's find the slope of our original line first. So 4x minus 5y equals negative 15. Let's go ahead and isolate our y first, because that's going to give us the slope the most clearly. So negative 15 minus 4x, and dividing by negative 5, we end up with y equals 3 plus 4/5 x. So our original slope is 4/5, meaning that our parallel slope will also be 4/5. And I really hope that you get in the habit of writing this down, because it'll just make life so much easier for both the reader and you moving forward. So with all that information, and I'm going to make this a little smaller to give myself some room, we now have all the info we need to create this equation of our new line. Because it'll have a slope of 4/5, it'll contain the point 7, 9. So we've got y minus 9 equals 4/5 times the quantity of x minus 7. Boom. All right, now that we've discussed lines that are parallel to one another, now let's explore the relationship between lines that are perpendicular to one another. So first things first, what does it mean for two lines to be perpendicular to one another? Well, two lines are perpendicular if they intersect at a 90-degree angle. So I've done my best to freehand that. So if that is a 90-degree angle, a right angle, then we would say that these two lines in red are perpendicular to one another. And so the first question we have is, well, what's the relationship between the slopes of two lines that are perpendicular to one another? Now we know that the slopes of parallel lines are the same, and that was probably a lot easier. We could just kind of look at it. But this is going to be a little bit more tricky, so let's go ahead and do a little investigation where let's draw lines that are perpendicular to one another and compare their slopes. And as we do that, I'm going to catalog here pairs of perpendicular slopes so we can see if there's a relationship. All right, so here we've got two lines, one in blue, one in red, that are obviously perpendicular to one another. And I've created it so that if we move one of these lines, they will both stay perpendicular to one another. So let's explore the relationship between their slopes. The first thing I notice is that if this blue line has a positive slope, then the red line has a negative slope. And if we continue to rotate, and now if the blue line has a negative slope, now the red line has a positive slope. So, all right, one thing we've noticed is that the signs of the slopes are always going to be opposites if we're dealing with perpendicular lines. I also noticed that if the blue line has a very small slope, then the red line happens to have a very large slope, right? If the blue line is kind of shallow, the red line is steep, and vice versa. If the blue line is very steep, the red line becomes very shallow. So let's actually investigate some numeric examples. So for instance, if the slope of the blue line were positive 1, it appears that the slope of the red line would be negative 1. Okay, interesting. If the slope of the blue line were positive 2, what's the slope of this red line? I think the slope of this red line is negative 1/2. Interesting. If the slope of the blue line were positive 1, 2, 3, the slope of its perpendicular line would be negative 1/3. Interesting. I seem to see a little pattern arising. And let's pick a fraction slope. Like if the slope of this blue line were positive 2/3, the slope of this red line is negative 3/2. Interesting. So let's see if we can formalize our findings looking at these pairs of slopes that are perpendicular to one another that we just found. Well, it appears to me that whenever we have two perpendicular lines, to go back and forth between their slopes, all you need to do is change the sign of the slope from positive to negative or negative to positive and find that slope's reciprocal. So the reciprocal of 2 is 1/2, and the reciprocal of 1/2 is 2. And of course, their signs are opposite. Or for instance, the reciprocal of 2/3 is 3/2. The reciprocal of 3/2 is 2/3, and of course, their signs are opposite. So in general, the slopes of perpendicular lines will have opposite signs, and their magnitude will be reciprocals of one another. So let's go ahead and use that to do some example problems. So for instance, let's find the equation of the line perpendicular to 4y minus 9x equals 12, containing the point 1, 6. So the first thing I think we want to do is actually find the slope of this original line. So 4y minus 9x equals 12. So let's find its slope by isolating y and putting this into slope-intercept form. So let's see, we've got 4y equals 12 minus 9x, which means that if we divide by 4 and isolate y, we end up with y equals 3 minus 9/4 x. So our original slope is negative 9/4. It's kind of a nasty slope, but that's okay. Which means that our perpendicular slope, perp for perpendicular, well, it'll definitely be positive, right? It's going to have the opposite sign of the original slope, and it's going to be the reciprocal as well. So positive 4/9. So now that we've got this slope, we've got the point 1, 6 that this line has to contain. This is easy peasy. The equation of our line will be y minus 6 equals positive 4/9 times the quantity of x minus 1. Of course, you are welcome to put this into slope-intercept form, but this is my favorite form of the equation right here. Awesome. So with this information, why don't you take a crack at doing this one on your own? So please find the equation of the line perpendicular to 9y minus 2x equals 18, containing the point -8, -4. So why don't you pause the video, give this one a try, and then play the video, and we'll see how it went. All right, per usual, the first thing we want to do is find the slope of our original line. So 9y minus 2x equals 18. So in order to do that, let's go ahead and isolate our y. So let's add 2x to both sides. So we've got 9y equals 18 plus 2x. Divide both sides by 9. And we end up with y equals 2 plus 2/9 x. Okay, not so bad. It appears that our original slope is 2/9. So original slope equals 2/9. So our new perpendicular slope, perp for perpendicular, is going to be of the opposite sign. So it's going to be negative and the reciprocal 9/2. And so equipped with that slope, in this point, -8, -4, we can create our equation as y plus 4 equals -9/2 times the quantity of x plus 8. And that is the equation of the line, which is going to be perpendicular to this original line and will also contain that point. So, hope you found it helpful. Hope you enjoyed.